build this in because we know that d theta over dt eventually will be equal to our what? Will be equal to our omega. Okay. Okay. So now again, this point is fixed, and we know that this direction is our variable x. Okay. So if you look at all the problems that we have a fixed point and a distant x. I want you to do pattern recognition. Okay. The previous problem, we also have a what? We have also a fixed point, and we're going to relate with what? With x. The first problem that we have a fixed point over here, and now we relate with a distant what? Y. Can you all see when to apply absolute motion analysis? Okay. Now, if you have both x and y, this is out of the question. Forget it. No way, Jose. Are we clear? Okay. But don't worry. Doing your term test, I will tell you what to apply because I can understand that you are learning. But in your final exam, you have to determine. Are we clear? Okay. So from here, we have to relate the distance x. I'm not looking for this. Okay. So what we have over here, right? We have to relate. So I'm going to try to, so we know, what do we know? We know that this angle over here is what? 180 minus pi, right? Then we are also aware that this angle over here, right? This angle over here will be equal to 180 minus pi plus by theta plus by, I'm going to call this angle alpha is equal to 180. Not alpha is not a good word. Alpha is not a good alphabet. Tau. Okay, I call it tau. So tau is equal to what? Pi minus by theta. Okay. So we know that this angle over here is pi minus by theta. So we are going to use sine rule. Right? We are going to use sine rule. So we know that x over sine pi minus theta is equal to L sine 180 minus by pi. Okay. So we can determine what is our x. Now, we have theta is good news, okay? Theta, having theta down here is good news. But before or then we relate x is equal to L sine pi minus theta over sine 180 minus pi. And then if you use your calculator, you realize that L sine pi minus theta over sine pi. Now at this stage, it might look complicated, but it's not. Okay. Remember what I taught you to do, right? So always remember pi and L are what? Constant. Right? So that is good news because you can what? You can gather this term and not differentiate them at all. They are constant. Yes or no? And theta is a function of time. And we know from taking the time derivative, we can determine our omega. Okay? So what is left to do is just to differentiate. So dx by dt will be equal to L over psi pi, right? And then we differentiate cos pi minus theta, and then this is with minus d theta over dt. So this in terms, right, dx by dt. So if you look at dx by dt, right, is in fact equal to what? Is equal to our v. Okay. So from here, we can write out v is equal to L over sine theta cos pi minus theta, and then we have minus omega over here, right? So we want to find out what is our omega, right? So minus omega is equal to v sine theta over L cos pi minus theta. Okay. So note that v is moving from where? Right to where? Left, right? So v is moving from right to left. So therefore, minus omega is equal to minus v sine theta over L cos pi minus theta. And finally, omega is equal to v sine theta over L cos pi minus theta. Remember what I told you? It must be what? Positive. Yes.
I think you might have actually switched the sine phi to sine theta between going from dx to dt.
Where?
So for dx over dt equals L over sine phi, and then the next one is L over sine theta.
Ah, thank you. Yeah, I made a mistake there. Thank you for warning me. 1 pint. This is the problem for doing 1 hour 30 minutes of math without stopping. Okay? Not that bad, right? Okay? I hope. So what I'm going to do now is I'm going to stop recording here, and I'll